All right, let's talk about Schrödinger's cat. We're going to crack open the box on what is, without a doubt, one of the most famous and probably most misunderstood ideas in all of science. You've definitely heard of it, right? I mean, this cat is everywhere. One minute you see it in a serious physics debate, the next it's a punchline on a sitcom. So what is it about this particular idea that's grabbed us and just won't let go?
Well, as the one and only Neil deGrasse Tyson put it, it's become this ubiquitous intercultural reference. It's totally broken out of the physics lab. It's one of those things almost everybody knows of, even if they're a little fuzzy on the details.
So, what does it actually mean? Let's get into it. And to do that, to really get a grip on this, we have to untangle a massive misconception first. It's a classic mix-up that trips just about everyone up. Yeah, this is where it all gets messy. A lot of people think this whole thing is about how our minds, like our consciousness, can change reality. But the science, it's way more grounded than that. It's all about the physical world. And it boils down to one crucial difference: the difference between just observing something and actually measuring it. Okay, so look at this. On the one hand, you've got this really popular idea, the observer effect. This is the sci-fi version, right? The idea that just by looking at something, our human consciousness actually changes it. But then you have the real science, the measurement effect. And this is completely different. It says the physical act of measuring something is what changes its state. See, the human mind isn't even part of the equation here. Right, so if it's not our minds, then what's really going on? What's causing this change? Let's zoom in on the actual quantum principle at play, because it's not mystical at all, it's a straight-up physical problem. Think about it like this. It's called the photon problem. Imagine you want to see a super, super tiny particle, like an electron. How do you do it? Well, you have to shine a light on it. But what is light? It's made of photons, and photons carry energy. So when that photon zips in and hits the electron so you can see it, bam! The energy from that photon literally knocks the electron to a whole new spot. So the very act of trying to see where it was changed where it is. And this is the absolute key takeaway. It's the measurement device. It's the photon that causes the change. Not your brain, not your consciousness. This whole thing would happen exactly the same way if a robot in a locked room recorded the data. The human mind is totally irrelevant to the process. Okay, so with that measurement effect in our back pocket, let's finally open the box. How does this all lead to a cat? Well, back in the day, the physicist Erwin Schrödinger came up with this whole scenario. And here's the funny part. He didn't do it because he thought it was possible. He did it to show everyone just how completely bizarre the rules of quantum mechanics sound when you try to apply them to big, everyday things, like a cat. So here's the setup. Picture a sealed box. Inside, there's a cat. And let's be super clear, this is a thought experiment. No cats were harmed. Anyway, also in the box is a tiny radioactive atom. If that atom decays, which is a totally random quantum event, it triggers a hammer, which smashes a vial of poison, and, well, you get the idea. The cat's fate is tied directly to a quantum roll of the dice. Okay, before we peek inside, we need to wrap our heads around a truly wild idea called superposition. This is a core rule of the quantum world. It says that until you measure a particle, it doesn't exist in just one state. It exists in all of its possible states at the exact same time. It's not A or B, it's kind of A and B all at once. And that's the punchline of the whole experiment. Since the cat's life or death is chained to that quantum atom, and that atom is in a superposition of both decayed and not decayed, then the cat must be in a superposition too. So until we open that box and make a measurement, the cat is, according to the strange logic of quantum mechanics, both completely alive and completely dead at the same time. The act of looking, of measuring, is what forces the universe to, pick a side. Okay, I know, it sounds completely bonkers, right? A zombie cat? But here's where it gets really interesting. This exact weirdness, this concept Schrödinger thought was so absurd, is actually the engine behind some of the most cutting-edge technology on the planet. Think about the device you're watching this on right now. It works on bits. A bit is simple. It can be a 1 or a 0, on or off. That's it. But a quantum computer, it uses a qubit. And a qubit, thanks to our friend's superposition, can be a 1 and a 0 at the very same time. This is a total game changer. A qubit can hold so much more information because it's not just yes or no. It can exist as a probability. It could be, say, 80% 1 and 20% 0. It lives in that murky in-between state, just like our cat being both alive and dead until we check on it. So isn't that amazing? The very idea that Schrödinger cooked up to show how weird quantum physics is the exact thing scientists are now using to build the future. This ability of qubits to be multiple things at once gives quantum computers a kind of superpower. They can work on solving incredibly complex problems, things in medicine or creating new materials, that would take today's best supercomputers literally millions of years to crack. So it all leaves us with this one kind of mind-blowing question, doesn't it? This thought experiment was meant to be a paradox, but the principle behind it is not only real, it's powerful. So if the very act of measuring reality changes it, it really makes you wonder, what's everything really like when we're not looking?